Jason Wielinski with Heritage Research. His topic is recycling trends with regard to sustainability.
So I'm going to talk about recycling trends with regard to sustainability, talk a little bit more about deeper type of pavement treatments and how we recycle and use our existing pavements to build new roadways. So let's talk about, what do you think of when you hear the word sustainability? There's a lot of different industries that use the word sustainability. Heritage is in waste management. We work with a bunch of industrial customers, help them with their sustainability goals. There's manufacturing folks that work on sustainability. I looked up a lot of definitions, and the one I really liked was, sustainable development is development that meets the needs of the present without compromising the ability of future generations to meet their own needs. So what type of things do we think of when we hear statements like that? Green comes to mind. How do we stay green? Reduce waste, recycle, reuse. How about retire? What do we do with materials when they're end of their life? How do we handle them? How do we handle wrap? And if we're going to be sustainable with pavements, we have a lot of other things to be mindful of. We have the environmental impact, and how do we reduce that footprint or impact on greenhouse gases? But we also have to be mindful of cost. If it's green and it's good technology, but it's 3 or 4 times more expensive, does it make sense fiscally to do that? See a lot of head shaking, no. And we have to understand performance. We have to understand the social impact, because if we're going to go a sustainable route or a recycle route, we want to make sure that we're getting performance in that roadway equal to what our alternatives are. So let's couple those 3 things in mind while we talk about some of these treatments today: environmental impact, cost, and how these things perform over time. Let's talk about wrap. Where does reclaimed asphalt pavement go? I live in Indianapolis, heavily urban area. We have wrap piles all over the place. The wrap pile's so big, they put a little reclaimer on top to help crush them down, and it looks very, very small from the roadway. We reuse it in hot mix asphalt. Tried and true method. We see contractors that use it as shoulder aggregate. Maybe even worse, they use it as fill material. And the last thing we want to do when we talk about retiring wrap, put it in a landfill, right? Because we're just occupying space. Let's talk about, are we capturing the maximum value of that material? So I'm going to talk about the cold recycling processes today. There are full depth reclamation, cold in place recycling, and cold central plant recycling. My colleagues from ERA, they're going to be talking about the 4th recycling technology after me, which is hot in place recycling. But at the end of the day, I want us to keep in mind with these technologies, we're building roadways, we're using less resources with proven construction methods. These are engineering processes, engineered equipment, engineered designs with engineered technology. And ultimately, and this is a clip from Road Resource, which Rex is going to talk about later, we want, as pavement managers and pavement designers, we want to increase that overall network condition, right? We want to keep those PSI values high, PCI values high. And we want to do it for the lowest cost, with keeping a green aspect in mind, the eco-benefit, if you will. So here's a little snapshot of what the 3 processes are, and really quick, I think our agencies have any experience with full depth reclamation in here? A couple hands up. So it's the deepest treatment. We're going to get through all the asphalt pavement. We're going to incorporate some of the aggregate base or subgrade depending on the needs of the road. We're going to use a bituminous stabilizer, a foamed, or an asphalt emulsion, or if we're getting a lot of subgrade in that mix, we're going to use a Portland cement stabilizer. So FDR, if you want to picture where would I use this tool, this is an alternate to complete reconstruction, remove and replace. This is where we can grind the roadway back to an aggregate granular layer, and we're going to stabilize that for a homogeneous base. Cold in place recycle is the 2nd treatment. Typically, we're looking at 3 to 5 inches in processing depth. That milling machine goes down the road, just like a regular milling machine. But instead of putting it in a truck and hauling away, we're going to add a stabilizer in-house, and we're going to throw it right back in a paver and lay it in place. So an agency might use CIR as an alternate to a deeper mill and fill type treatment, where you have to get into the pavement a little bit deeper. Cold central plant recycle is where we're taking that wrap to a nearby location, close to the job site. We're going to put it through a pug mill. We're going to add a stabilizer to it, truck it back, and we're going to use that as a structural base layer. So those are the three cold recycling technologies where, you know, we can reuse the existing pavement, we can reuse existing wrap, and build very good performing pavements. Just in general, keys for successful recycle projects, it comes back to right road, right time, right treatment. And a lot of it's with process selection, and we could stand up here all day and talk about process selection. It is an engineered process, so to ensure good projects, you got to understand the scoping up front, identify the distresses, where they're coming from. You got to do proper pavement design, understand your stabilizers and mix designs, and perform quality control. So you can take a road like that, perform a CIR, cap it with an HMAL overlay, and get performance that looks like that after years. So let's just keep that in mind as you design these projects and build these types of projects, that there's a lot of work that goes up front, before scoping, during construction, and afterwards to make sure that they perform well. So here's a little schematic just to keep in mind what the CIR process does. So let's say that we have cracking in the top 3 to 5 inches. That milling machine's gonna go through, grind it up, lay it back in place. We can lay it back on place on existing HMA where we don't have any bottom-up cracking, where it still has some remaining life in the bottom layers of that pavement. So we're gonna address a lot of the top-down issues. Depending on the pavement, we can go all the way to the aggregate base if we need to. So here's a little video of what the CIR operation looks like. So there's a video of this is a project in southeast Michigan that had the opportunity to be a part of. So this is what the train looks like. First up, we have a water tanker. It's plumbed the machine. We're gonna add a little bit of water into the cold recycling process to help with the mixing of the emulsion and the wrap. It's gonna push an emulsion tanker. That emulsion tanker is delivering about 2.5% emulsion to the wrap during the process. And it all goes into that machine, which is engineered to control the rate of both the water and the stabilizer that goes into the wrap based on the speed and the cut depth of that material. You can kind of see the pavement here, kind of the cracks that we have. This is a composite type pavement. The machine cuts 12.5 foot wide, so it cuts a full lane width. Kind of see that milling machine's going down and grabbing all that asphalt. We're gonna take all those asphalt, we're gonna eliminate those cracks. We're almost down all the way to the bare concrete. That wrap then goes straight into the hopper of the paver and then gets laid right back in place. Relatively homogeneous mixture coming out, and then it's going to get compacted down the roadway. You can kind of see a little bit of what that looks like as it gets seeded. So after it gets compacted, we're going to leave that CIR open to traffic because it has enough strength to put traffic on it. We're going to let it breathe and we're going to let it cure out a little bit. We're going to let some of that moisture get out, and then we're going to cap it with some sort of surfacing layer. What don't you see in this process? You don't see heat. Well, the milling machine's a little bit of special equipment. You don't see heat, so there's less energy. You don't see trucks. So the other alternative to fix that roadway would be to mill those 4.5 inches of asphalt up, load it in a truck, take it off to the nearest site, bring back brand new asphalt, right? So there's that green benefit of the trucking, right? Because, they consume fuel. They release gases in the environment as they work. But let's just think from a safety standpoint, too. There's a lot less truck traffic in and around that roadway for the other traveling public. So let's keep that in mind, too, when we're talking about sustainability of some of these recycling type treatments. Let's talk a little bit about how they perform. And I'm going to talk about a project that we had the opportunity to be a part of here in West Virginia. This was a CIR project constructed in 2015. And I think a lot of folks have this idea where a lot of these recycle type treatments, they're only good for lower volume roadways, low speed roadways, right? We got to understand these treatments so that they get applied to low volume roadways, but we got to also apply them to some of these high volume roadways, high speed roadways. And this stretch of State Route 2 near Ravenswood, this is a 4-lane divided highway. There's a lot of trucks, there's a lot of traffic, there's a lot of speed. Pavement was the pavement even before the project started was in such dire condition that there was actually an emergency inlay before the project even started on that driving lane. It was a composite pavement, so there's some concrete laying underneath all that asphalt. Ultimately, it was a 64,000 square yard CIR project. And again, as I mentioned, it was built in 2015. So let's take a look at what that pavement looked like. What do you guys see here? A lot of cracks, right? From what? Composite pavements crack funny because the joints reflect through, and a lot of times as those come up through, the other parts tend to crack around with it. Travis, you mentioned some environmental cracking. What do you think that ride's like for our traveling public? You're bouncing up and down. Travis, that data before the CIR was about an IRI of 140, 150, in that range. So that's what that pavement kind of rode like for our public, our social impact, if you will. Here's a shot of the little inlay they put on top in that one driving lane. This is us out taking cores to collect mix to do a mix design. This is what those cores look like. Who said ouch? Yeah. Got a lot of cracking underneath all that. That's going to reflect through, right? So that's causing a lot of our problems as well. So if we would have just done a single lift, mill and fill, what would we have expected? Probably within the first 1 or 2 years, allow those cracks to come back, right? I see some nodding here. So here's some shots of the construction. This was an emulsion project, and on this one, we actually added a percent of cement in the formulation to help set it up. We were cognizant of the fact that we were going to have some traffic on it early, particularly in some of these intersections. When we're done compacting these mixtures, we like to put traffic on them. Well, what happens when it's slow-moving, turning truck traffic? What do those wheels like to do to mix, right? Think of the forces. It's a shear force, right? And if that mix isn't set up, and if it's not hard enough, and it doesn't have cohesive strength, what are we going to expect that mix to do? It's going to tear and shove and push and scoot all over the place, right? Well, after a few rotations of trucks going through, you can kind of see the tire marks, and you can kind of see where maybe it's picking up the loose ends of that mix next to that adjacent lane. But ultimately, you can see that mix didn't shove, push, tear, or anything like that. So as agencies try to understand and use these new technologies, you got to be cognizant of how do I optimize the performance of that mix to get the expectations that I want during construction, understanding that we're going to expect to have traffic on it relatively quick. So performance. That's a shot of the same roadway that was taken this past fall. So 2018. Remember, built in 2015. Here's down close to that same intersection. Got no rutting, got no tearing, no distortion of that mix. Here's a shot of that roadway that I took in the rain on Monday. Always like looking at pavements in the rain, right? You can see a lot more. You see cracks coming through. Some of the data that has been shared with me from the West Virginia Department of Highways, you know, that our IRI was in the 140s before the CIR. Well, the 3 years after it, after the CIR, that pavement still has an IRI below 70. And it has a single lift of hot mix on top of it, 1.5 inches, right? So I would say that's pretty good performance for 3 years considering what was there to start with. Any questions on the CIR type process? So the question was, can you do it without capping it? And I think the answer, the best answer is probably not the best idea. And this is the reason. The CIR layer, it's going to have a little bit higher void content than our traditional hot mix. So it doesn't quite have the environmental durability, especially in kind of these northern climates, to withstand that. So we want to make sure that we get a cover on them. Single lift at HMA or a couple lift HMA, depending on your traffic. In extreme low volume routes, we've successfully seen projects where they're doing double chip seals or cape seals on top of them. So it goes back to the traffic loading and expected performance. But I do not recommend to not surface those. You want to seal them up to make sure you're keeping the water out.
Right down to residential applications using emulsified asphalt. They basically, and those those get capped within 2 weeks. But it's been ongoing for 20, 30 years.
Yeah, the idea is not new. The idea of recycling actually kind of first started in the 80s. Well, what's happening is the technology, the equipment, the mix design process, the protocol process, all that technology is developing to get us much better and optimized performance. So let's talk about another sustainable type of treatment, and it's called cold central plant recycling. So how many times do we run into a pavement where we have a considerable amount of asphalt pavement on top of a problem layer? So that can be a concrete, piece of concrete that's got damaged joints, or it's rotten and falling apart, or it's a subgrade with low strength. Well, what if we took that asphalt on top of it, and instead of taking it back to the nearest hot mix plant and put it in the pile, what if we piled it up close to the job site? We then would be able to fix subgrade concrete panels, what have you, underneath that asphalt pavement. And what if we just took that stockpile, add a stabilizer to it, and pave it right back in place? Now, I'd like to share with you a project that we had the opportunity to be a part of in Indiana. This is State Route 101. This was a project in which the department had 8 miles of roadway, northeast Indiana near Fort Wayne. It was a hot mix over an aggregate base over low strength subgrade. It had extremely narrow travel lanes, 10 feet lanes, where we were getting 1,700 trucks per day, and they were sharing the road with some Amish buggy traffic too. So the idea was, well, how do we widen this pavement to enhance safety? We need to increase the subgrade strength so we have a good solid foundation. They ended up employing a combination of recycling techniques. So here's a shot of the roadway. They had asphalt. It was 20 foot in width. And what they elected to try to do, and this was the first time they tried these processes together, they took 8 inches of that existing asphalt off the top. They took the remaining aggregate base, subgrade, shoulder material, and what they did is they actually performed a 26-foot wide cement FDR. So they're going to build that foundation. They took that stockpile that was only 10 miles down the road, instead of 25 miles down the road to the nearest hot mix plant, and they paved it back in a single 6-inch lift as a cold central plant layer, and then they capped it off with 2 inches of hot mix asphalt. The general contractor on the project was Brooks Construction, and Brooks actually put together a really nice video that's available on YouTube. So I wanted to share that with everyone here today, because it really helps demonstrate and shows how the process works. So there's an idea of what the roadway was like. A lot of truck traffic, pretty narrow lanes. And they ask the question, as they start showing the milling, is how many tons of wrap do we take off the pavement each year? And what do we do with it? And I would have to say that working with Brooks, who's a pretty heavy hot mix contractor in that area, they were great to work with understanding this new process. As I said, this was NDOT's first CCPR job, and they picked a 9-mile stretch to do it, so it was quite the demo type job. That's what 9 miles of wrap looks like in a nearby location. So they take the 8 inches of asphalt off, and they take it back to the plant, and they do what we call processing. So what the processing really entails is crushing and screening that wrap down to 1.5 inches, 1.25 inches minus, so that we get continuous graded material. They were able to do some pipe work, some pipe crossings to enhance drainage, and they were able to build that platform for the cement type FDR. So we're going to create that stable platform to put our flexible pavement on top of. So how much material did they import to do that foundation stabilization? They just brought in the cement, right? So 5% of that 10 inches was new material brought in. Here's a shot of the pug mill, what it looks like. That pug mill was making 300 tons per hour. And across 17 days, that little pug mill made 37,000 tons of mix and supplied it to this job. And I mentioned that pug mill was only 10 miles from the job versus the 25 miles compared to the nearest hot mix plant. You know, how many trucks do we have for 37,000 tons of mix? It's a lot of truckloads, right? Multiply that by 15 miles back and forth. Saved a lot of money on trucking as well. Went ahead and put a 2-lift asphalt layer on top of it. We actually profile mill the central plant afterwards to help with ride and cross slope, which is one thing that we're doing in Indiana with our recycles to help with ride, and it also helps with bonding. Those styrations from the milling help create a little bit better of a shear plane for the surface and the underlying layer. And ultimately, brand new roadway. Let's do some math. Talk about sustainability, talk about reuse. 10 inches of that base subgrade, 95% of that was already there. We brought in 5% of the cement. The cold central plant mix, 6 inches thick, approximately 37,000 tons. We used 2.5% emulsion. Cold treatment, we didn't even have to heat it up. We didn't have to use as much energy during production. So that layer was 97.5% recycled materials. Then if we consider the HMA overlay at 2 inches, which I would assume probably had 15 to 20% wrap in it, that pavement rebuilt 16 inches thick definitely had over 90% recycled material in it. So the question is, well, what did it cost? And some of the statistics I've heard is that central plant layer is probably 30% more cost effective than traditional methods. So across 9 miles, 37,000 tons, the department saved a good amount of money on that project. So there's a lot of other resources and tools out there to gain a lot more information about how these things work. Project 962, NCHRP project that VTRC is working on with others, they're helping find new quality control methods so that we're actually improving the engineering process of how these are constructed in the field. I know NCAT has test sections out on US 280, looking at central plant, CIR type layers and how they're performing over time. Where's our Virginia guy? Everybody's watching you guys too. You guys are doing interesting things there. So the same thing we did on 101 with a cement FDR and a cold central plant layer. Our friends in Virginia are doing the same thing on interstates, on added travel lanes. Everybody's interested to see how those projects come together. The data that Brian Diefendorfer is sharing on the first job showing that these layers are performing extremely well. So other tools that exist, roadresource.org. Rec's going to talk about it a little bit later. It's a great website, talks about the recycle treatments, talks about all the preservation type treatments. Helps give you more information on how they work, how they're put together, which candidates are good for which treatments. We have AASHTO specifications out and available as a resource for states that want to develop their own spec or just their current spec. And there's a lot of training available too. NHI courses, the cold in place recycle NHI course is really good. So those resources are available and out there to understand how these things work, how they perform, and how they can save money and give agencies an eco option for restoring pavements. So ultimately, goes back, right road, right time, right treatment. Goes back to process selection. Engineered process, that's how we're going to get good performance out of these. That's how we're going to get that social impact. Make sure that we're using a treatment that provides good performance in the field for our driving public. There are cost savings realized by agencies using these tools. It varies by geography, but they're typically less cost than some of the traditional methods available. And there's a significant impact or less impact on the resources out there. Think about the reuse option. We're gonna recycle that material in place. We're gonna reduce trucking. So we're gonna create a little more sustainable pavement than what we would if we were ripping everything out and bringing back in new material. Are there any questions? The way the contract was written, or the way that the job was described, the milling was a separate operation. Pay item, remove the wrap. And they specified they want 6 inches placed back down. So it made sense for the contractor. The contractor could have taken the wrap off and gone anywhere and brought back a new central plant type material. But the fact was, it was easier just to truck it 10 miles down the road, he'd process it there and bring it back. So there was no language that actually said possession of wrap or whatnot. They actually specified what material they wanted there. So it made sense from a contracting point of view to utilize the material that was already there. The question was, has any tire rubber been used in the emulsion for some of these recycling processes? I'm not familiar with any of that material being used, but that's not to say that someone else has tried it. I just don't know for sure.
Jason, you mentioned earlier that the air void content is different for these pieces. Can you elaborate on what people should expect to see in those air voids?
Sure. So what do we typically expect of our in-place hot mix asphalt? 6 to 8%. We're working on another project. It's called SEPPP 5, where we're trying to get that lower, but that's another topic. So these pavements typically, I would say, have air voids in the 10 to 14% range. But the size of the voids, they're really small, so it doesn't look open graded like a 14% air void hot mix. But that's kind of the numbers that we would expect in the field to achieve. Vince?
Given that extra air, can you talk about the fluff factor? So if you remove 6 inches, all that material isn't going to come back. So how much extra material would you have?
Right, it's the same concept. If you dig a hole and you try to put it right back, it's hard to get it back flush with the hole that you started with, because you're not compacting it back as much, right? You don't have as much energy to get in there. I think a good rule of thumb is probably 10 to 15% of your cut thickness. That would kind of be the fluff that you might expect. So, you know, in projects where you might have like a curb and gutter type situation, where you have to take a little bit of asphalt off, you can treat what's left and then cap it back with your new layers so that you're matching curb reveal. It's a good place to be cognizant of what that fluff's going to be. Scott? Great question. The answer is yes. We have experience with doing that on some local type projects. So there are milling contractors that have wrap piles that can use that as a source. So it's been used in county highways. We pave it on county highways. We've used it in some residential type applications as a base layer. The important thing to do is just make sure that you have a good understanding of what that wrap pile looks like. It's free of trash, it's free of debris, it's free of wood, it's free of clay, things like that. And it still needs process to the sense that we need to be focused on top size and make sure it's continuously graded. If you have that control of that wrap pile, it can be easily done. Yes?
Guidelines on like how far gone it can be because of cracking and stuff like that, but they still be a good idea to do recycling?
Great question. Did everyone hear it? Was what kind of guidelines are available to help me identify if the pavement is too far distressed for these treatments? So a couple tools that do exist. Roadresource.org has great built-in tools to help identify, look at the type of cracking I have, look at the type of distress I have, and it helps you identify which treatments you might want to be leaning towards. The Asphalt Recycling and Reclamation Associations have guidelines out there. The Basic Asphalt Recycling Manual is another good tool that kind of helps describe based on which distresses exist, which of these treatments might be best suited for the pavement. You're welcome. All right. Well, I appreciate everybody's attention early this morning, so thank you.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.